Hi guys, welcome back to Calculus. Today we're going to talk about 5.4 increasing, decreasing intervals and the first derivative test. So what we'll be doing is we will be looking at a graph and identifying characteristics. Now back in your pre-calculus days, you would have questions like this, where you would be given the graph of f of x, and then you had to identify characteristics of f of x. So you would look at the graph, and if you, let's say you were asked to determine where f is positive. Well, I know that positive means where the y values are positive, or where the graph is above the x-axis. So I would have looked at this graph and I said, okay, well, this graph is above the x-axis in this highlighted portion and in this highlighted portion. So those are the positive intervals of f of x. And so I would have given those. Now I'm going to estimate that's about negative 5.5. So I've said from about negative 5.5 until negative 2. And also, let's scroll over a little bit. From this part, that x value from about 3 until infinity. Likewise, if I were asked for the negative intervals of this graph, I would look at the graph to see where it would be below the x-axis, where all the y values are negative. And I would have said, okay, well, it looks like it starts from x equals negative infinity. So from negative infinity until x equals about negative 6. And then f of x is also negative from negative 2 until positive 3. And that's how what you would have answered the questions in pre-calculus. You had questions about f, you had a picture for f, and you answered those. Well, now in calculus, what you'll be given is you will be given a graph not of f, but of f prime. So this lesson will be really important to look at the labels of the graph, and then you'll be asked for the graph of f. So you'll be asked to identify characteristics of a graph that you can't even see. You have its derivative, or you might have f, and then you're asked about f prime. So in just a minute, we'll get back to this chart and figure out how we do that. So this chart's going to be super important. You'll want to highlight or star or put a heart next to this chart because you're going to use it all unit. But let's look at what's happening here. So on example 1, you have a static picture of what you'll see in Delta Math. Now in Delta Math, let me pull up my Delta Math right here. Here's another example similar to what you had. But if you'll notice on this example, I am given the graph of f. So I'm going to label, even though it's labeled, this is f of x. And then they also give me some values for f prime. Okay, so I'm going to look at that and see what happens. Now, as I move this dot along that line, those values of f of x, they change. So over here, those f values are positive. Sorry, f prime is positive. And the reason you're seeing a line is because we're thinking of the derivative as the slope of this tangent line. But as I move it along, when I get to the top, notice, if I can stop it right there, at the top, the tangent line has a horizontal slope. So the value of the tangent line is 0. And then as f starts decreasing, those derivative values are negative, and they stay negative as I trace until I get to where f increases again. And now these derivative values are positive. So that's one thing that we need to remember for our chart. I'll come back up here. That if f is increasing, and what that means on the graph of f is that it goes up from left to right, f prime will be positive. So you look for where f prime would be above the x-axis. When f is decreasing, going down from left to right, its derivative is negative. In other words, the derivative is below the x-axis. A relative maximum can either be like at a curvy relative maximum, or you might even have a pointy relative maximum, but those top points right there. And on F, what you'll notice is that the graph of F changes from increasing to decreasing. So we look for a change, increasing to decreasing. But on the derivative, instead of seeing a change from increasing to decreasing, when F has a relative max, you'll see F prime change from positive to negative. And then the reverse is true for the relative minimum. So relative minimum, let's see, make this a little bit thinner. There we go. They happen at the bottom, or at the bottom of a pointy part, and you'll see the change on the function of F decreasing, and then it will change to increasing. But the derivative, when F has a relative minimum, F prime, you'll see a change from negative to positive. And then just a reminder, whenever you read a graph, we always read our graphs from left to right. And then whenever you see a max or a min or a critical number, then the derivative is 0 or does not exist. And that's what happened when we got to like this. There's a relative maximum for F right here. And you'll see if I can stop, the derivative value is 0. So we're going to skip down to, we'll come back to, actually we'll do example 1. It says, now we have the graph of F. And so we're going to determine all the intervals on the open interval where F prime is less than 0 and where F is greater than 0. Now notice they're asking me about two different things. They're asking me about F and F prime, but I only have a graph of F. So we'll start off with the F part. So F of X being greater than 0, that means they want me to find the positive intervals. So I'm going to highlight the positive spots where the graph is above the x-axis. So from -7 to -3, and then from x equals 1 until x equals 9. But at the same time, I also have to figure out where f prime is going to be less than 0. Less than 0 means negative. So let's see, if f prime of x is less than 0, then that means I'm going to go to my chart and say, okay, when f prime is less than 0, when f is negative, then that's also where f would be decreasing. So that means I also need to look for where f is decreasing. So then I look at my two highlighted portions and I say, okay, well, it starts off increasing, but then right here to here, decreasing. And then f of x increases, and then at 6, it starts decreasing until I get to 9. So the places where both of these are happening are the interval from -4 to -3 and from 6 to 9. Okay, now we're going to skip down to example 3. And on example 3 gives me a graph, and I notice I need to look and say, okay, this is the graph of f prime. Have the graph of f prime, and I want to find out where f is increasing. But I don't have the graph of f, I have the graph of f prime. So I have to figure out, well, what's f prime doing when f is increasing? So I'm going to come over here and I'm going to say, okay, I know f of x is increasing when f prime, and I'm going to consult my chart. And I look, I say, okay, f of x is increasing when f prime is positive or above the x-axis. So f of x is increasing when f prime is positive. So then that happens, f prime is positive on this interval and on this interval. So I would say that happens from -9 to -7, and also from 1 to 9. Then I'm also asked to find the relative maximum and relative minimum. And also note here, these together, if you don't want to say relative maximum and relative minimum, these together are also referred to as relative extrema. Extrema is an umbrella term for maximum and minimum. So if it's a lot of syllables to say maximum, minimum, so sometimes you'll just hear someone say find all the relative extrema. And if they say find all the relative extrema, that means find the relative maximum and the relative minimum. You'll also hear the word local minimum and local maximum. And what you need to know is that means the same thing as relative. Okay, so let's talk about the relative. What do we want to do for? Let's do the relative maximum first. So I'll say f has a relative max when f prime changes. And if I look at my chart, go back to my chart, relative max for f happens when f prime changes from positive to negative. So f has a relative max when f prime changes from positive to negative. And also don't forget, you have to read your graph from left to right. Okay, so this first pink portion, the graph is positive. And then f prime changes to negative, and then changes to positive again. And I want to look for where that happens from positive to negative, left to right, and that happens right here. So that happens at x equals -7. Now I can't tell what the relative maximum is. I can only tell where it is. So that's why this at is pretty important. And then if I want to find, it also says I have to find the relative minimum. So I can say f has a relative minimum when f prime changes. And if I look back at my chart, I'll see that it tells me, my chart, I'll see that it tells me when f prime changes from negative to positive, left to right. And so I'll see that that happens at, let's see, at x equals -1. No, at x equals +1. So we just found where, this is the location of our relative extrema. The other thing they'll have an example for is very similar to example 3. The other thing they'll have you do is compare values. So notice on example 2, you're given the graph of f, but then they ask you about f prime of -4, f prime of -1, and f prime of 7. And what they're going to ask you to do is they're going to ask you to pretty much list those values in order. And so if I'm going to highlight like -4 on the graph shows up right here. And again, this is the graph of f, not f prime. And f prime of -1, that would be that point right there. And then f prime of 7. Well, if I look at -4, I see that -4 is on the part of a graph where f is increasing. So that tells me that f prime of -4, since it's on a part of the graph where f is increasing, then that tells me that f prime of -4 is positive. Seven, f is decreasing, so that tells me f prime of 7 is going to be negative. And then at -1, we've got that, we could draw a horizontal tangent line here. So I would know that f prime of -1 is 0, because we're also seeing a change from increasing to decreasing. So there needs to be 0 there. So if I were to list these in order, the lowest one, the smallest one, would be f prime of 7, because it's negative. That's less than f prime of -1, because that's 0, which is also less than f prime of -4. Now we are going to stop this video for right now. You might notice that there's some more to your notes, but next lesson we'll learn how to tell similar characteristics, but instead of using a graph, we'll be using some algebra. So until then, I will see you guys and have a great day.